Alrighty, we're going to do a video here on how to solve systems of equations, but this already assumes that you know how to substitute and how to do elimination. All we're going to do is try to break down a word problem and figure out how to get our two equations. We will go solve it, and we're going to look at the equations and see whether it's advantageous to use substitution or elimination, but the main goal here is to break down a word problem and find the two equations. So what I have on the screen right now is the procedure we're going to use, and when I say fill in the totals first, every word problem that we're going to do in chapter 7 deals with two very distinct topics, and we're going to try to find the totals in each of these topics. By the way, everything that we do here today is also going to be in standard form. So in standard form, we have the equal C on the right-hand side, and that C is going to be the main total. And then we're going to kind of assume everything on the left is a smaller part of that total. Hopefully you'll see what that means as we move along here. So here's a word problem that we're going to do. I work at Shipley, and Swamp Night is a big night for us where we go out and crush all the local rivals. So we're going to be selling tickets to Swamp Night. And we're going to have some student tickets, and we're also going to have some non-student tickets. And then after we have our Swamp Night, we raise our money, we find out the next week that we actually raised $3,125, and we did that by selling 475 tickets. So we want to know how many of the student tickets were sold and how many of the non-student tickets were sold. So let's bring up our procedure again. And number one says fill in the totals first because they are the easiest to find. So I know I'm going to have two equations, so I'm going to set my equal signs up right away. And my first total is right here, 3125, and my second total is 475. Now I want to know what that 3125 is. And that's actually going to be dollars. That's important because every little part of that total has to be in dollars. And over here on the 475, that's actually tickets. And so everything I want in there is going to be going towards the total of tickets. So once I have that, I need my two parts. And my two parts are basically going to be, how did I get the totals? I'm actually going to start over here on the right with 475. That's how many total tickets were sold. So what are my two parts? Well, I had a student ticket, and I also had non-student ticket. I'm going to call that NS. That might be a little unconventional. You're probably used to one letter for a variable, but hey, this is my problem. I can use any variable I want. Whatever works for you, you should use whatever you want. So I have all my student tickets, S, and all my non-student tickets, NS. I'm actually going to come down here and I'm going to declare that S is the number of student tickets and NS is the number of non-student tickets. And I think every math teacher in the world is going to want you to declare your variables, so consider my variables declared there. Now I'm going to come over here on the left-hand side, and I have $3,125. So how did I get the dollars? And again, there's going to be two things that add up to that. Now I know S and NS are going to be involved because they were involved over on the right, and it's the same story, so the same variables are going to be involved. So how do I turn student tickets into dollars? Up here, my student tickets are $5. So for every S I sell, or student ticket that I sell, I'm going to make $5. And for every NS, or non-student ticket I sell, I am going to make $10. So if I add up all my student tickets at $5 a piece and all my non-student tickets at $10 a piece, that's going to give me $3,125. I have my two equations, and again, This video is assuming that I already know how to solve the two equations, so I should be in a good spot. So I'm just going to pop over to the next screen. We'll figure out how to solve these things. And if I remember correctly, I had $5 for every student ticket, $10 for every non-student ticket, and that was $31.25. I also had my student tickets plus my non-student tickets was $475. So I'm going to step back here, just take a gander at the problem and figure out how am I going to solve this. And I think I'm going to solve for my s first. There's no coefficient, it's all by itself, so that's going to be an easy one. So all I'm going to do is come over here and get rid of that, which means I have to do it to the other side. So now I know that my s is 475 minus my ns. I'm then going to take my s and bring that over here, and every time I see an s on the left, I'm going to substitute in 475 minus ns. So there's my 5s plus my 10 ns equals 3125. And in where my s used to be, I'm going to put in 475 minus ns. Continuing right along, I got to do a little distribution, and what's that going to be? 2,500. I wish I was a little quicker in this. Let's go 2375. That sounds about right. 2375 minus 5ns plus 10ns equals 3125. I have a 10s minus a 5ns. That's just going to be a 5ns. And I'm going to have to take this off of both sides. And that should leave me with 8,750. Does that look about right? Yeah, I think it does. And if I divide by 5 on each side, divide by 5, that's going to leave me with non-student tickets are going to cost me $1,550. Now, they call this the substitution method. If it was me, I would call it the double substitution method, because I am then going to substitute that 150 so that my s equals 475 minus my ns, but we now know that the ns is 150, and so my s equals 375 minus 50, 325. So I would write that as ns equals 325 and 150. I would plug the 325 and the 150 in just to double check things, but that, my friends, is how to solve that word problem.